Hi, welcome back to another physics class. In this lesson, we'll continue with our lesson on moment of a force, and we'll use this example to further explain how to treat clockwise and anti-clockwise forces. In case you missed our last lesson, please do not hesitate to check the description below. We have placed a link to our last lesson. That said, let's get started. Our question says, a uniform rod of mass 100 gram, length 1 meter is supported on two knife edges as shown above. Calculate the reactions at the supports when a mass of 50 gram is placed 30 centimeter from one of the knife edges. Now, obviously, if you look at this question closely, we've been told that the rod is a uniform rod and it has a mass of 100 gram. Now, the first thing I want to do is to convert my units so that my 100 gram, converting my 100 gram, that will be the same thing as 0.1 kg. Now, because I'm talking of the force, my force is equals to ma, mass times acceleration. The acceleration in this context is acceleration due to gravity. That's mg. Now, my m now is 0.1 kg and my g is 10 meters per second square. That's times 10, which is equals to 1 Newton. That's why we have 1 Newton here. Now, remember, look at this closely. We have that the weight of 50 gram also, let's convert the weight of 50 gram. My weight of 50 gram will be the same thing as 0.05 kg. Now this now times my F for the 50 gram will be the same thing as ma, which is equals to 0.05 times 10, that's mg, which is equals to 0.5 Newton. So in place of your 50 gram, I can conveniently replace this with 0.5 Newton. Now for convenience, I want us to redraw our diagram. Now look at it this way. This is a uniform rod. Here's a uniform rod. It's a rod AB. The weight of this rod is concentrated at the center, and we know that from our calculations previously, the weight of this rod is 1 Newton. Now, since it's concentrated at the center, that means, and the total length of the rod is 1 meters. That means from each edges of this rod to this weight that's 50 centimeters. That's 0.5 centimeter. Now, I have a knife edge here, and from this knife edge to this weight, from this knife edge, let's start from this knife edge to point A, we're told is 0.1. So from this knife edge to the weight will be 0.4 centimeters. Now we have another knife edge here, and we're told that this also is 0.1 to this point. That's 0.1. Now let's take the reactions at the knife edge. Here I have a reaction here. I have another reaction here. Now my reaction here is R2. My reaction here is R1. I want us to take the moment about point D first, and this is 0. Now, notice this with moment of a force. When I'm taking the moment about D, the reaction on D becomes 0. The only reactive force I'll be considering here is R1. If you are taking the moment about C, the reaction about C becomes the moment on C. If you are taking the moment about C, now the moment due to this particular force on C becomes what? 0. Same thing happen here. The moment about this force on D becomes 0. Why? Because moment is equal to force times distance. And there's no distance within this force here and this point. So the distance here is 0. My force times distance here, it will become 0. Now, so we're going to consider the distance, the perpendicular distance between the reactive force R1 here and point D. Now, since from point R1 to this edge is 0.1 and point R1 to this edge also is 0.1, that means the distance between these two forces automatically is 0.8. Now, because from 1 meter, you can subtract 0.1 and 0.1, that's 2, that's 0.2, 1 minus 0.2, I'm left with 0.8. Now remember that a force of 0.5 Newton was suspended on this point. That's 0.5. And we are told that between this point and the nearest edge is 30 centimeters. That's 0.3. Now, if that's 0.3, that tells us, if that's 0.3, that tells us that now between this edge and this edge I have 0.8, and already between this force and this point you have removed 0.3. What do I have left between this 0.5 Newton and this point? What I have left is 0.5 in meters. Sorry, my distances have been converted to meters and not centimeters. Now we can now determine which forces are anti-clockwise and which force are clockwise. Now, if you look carefully, you see that my R1 is moving in the anti-clockwise direction. So R1 is an anti-clockwise force, while my 1 Newton and 0.5 Newton are both moving in the clockwise direction. Now, so that my sum of anti-clockwise, your sum of anti-clockwise will be equals to R1 times 0.8, while the sum of my clockwise forces will be the same thing as 1 Newton times 0.4 plus 0.5 Newton times 0.5 in meters. So that's this. I have 1 Newton times 0.4, that's 0.4, plus 0.5 times 0.5, that's 0.25. Now that is in Newton meters. So this is equals to 0.65 Newton meter. Now you know that for the summation for the moment about a point, we know that the total moment across that point is equals to 0 to come to equilibrium. Now, so that mx from our last lesson plus my will be equals to 0. In this case, I have 0.65 plus 0.8, or sorry, minus, because it's the anti-clockwise force, minus 0.8 R1 is equals to 0. So that 0.65 is equals to 0.8 R1. Now let's divide both sides by 0.8. 0.65 over 0.8 is equals to R1, which is equals to 0.65 divided by 0.8. For my calculator, that's equals to 0.8125 newtons. Now that's the reaction at R1. Now note that your total upward reactions must equal the total downward reaction for the body to be at equilibrium. So that I will say that R1 plus R2 is equals to 1 Newton plus 0.5, which is equals to 1.5. That is 0.8125 is equals to plus R2 is equals to 1.5. That means R2 is the same thing as 1.5 minus 0.8125, which is the same thing as 0.688 newtons in newtons. Now with this, I believe you now understand how to treat questions relating to moment. With this, I believe you now understand how to treat questions relating to moment of a force about a point. In our next lesson, we will still take another example to help you understand it better. Thank you, and see you in our next lesson.